Hey everyone! I want to take a small break from game-related content and look at a tool that I developed to improve a workflow of mine. One of my hobbies is hardware and software development with microcontrollers, and I enjoy working with things like Arduino and those style of electronic development boards. One development board in particular that caught my attention was an Atmel Explained kit. This particular one was a Atmel ATX 256 A3BU, I think is the microcontroller on it, but it had a nice little LCD display on the development board that had a really easy to use interface. The display itself was 32 by 128 pixels. That's 32 bits tall and 128 bits wide. And it had a pretty decent software library for doing things like drawing individual pixels to it or drawing shapes like lines and things like that. But it didn't really have a good library for drawing text. Or if it did, it had one specific kind of font style that you could use. And I wasn't super thrilled with that. I knew I could draw text to the screen by setting individual pixels, but that was a very naive approach, and when it comes to microcontrollers, it's hugely inefficient. Microcontrollers have less resources than, your general CPUs, so while on a desktop CPU you could do that, it's still terribly inefficient. You might not notice the performance impacts. On a small microcontroller, having to call functions to set each individual pixel is a massive performance hit, and I wasn't happy with that. So I started looking at how this display had its memory mapped out, and I found that it was set up so that the memory was in four 8-bit pages that were each 128 bytes long. This meant that the 32 pixel height was divided up between those four segments of memory, those four pages, and each had 8 pixels that corresponded to 1 bit in the particular byte of memory in that page. So I realized that if each character was only 8 pixels tall, that each page would correspond to a line of text on the display with the way that it was set up. Factoring in the width of the page, that meant that if I made each character 8 pixels wide, I could fit 16 characters per line, which ended up being 64 characters total on the screen. This is working out great, and I played around with changing the width of the characters, but I found that 8 pixels wide was about the sweet spot for making the characters readable and still having enough space between the characters. But I was finding that trying to set this up by hand was a real chore because I was having to go in and figure out the bit patterns for the characters by hand and trying to set that up and having to compile it and test it and see what it was looking like on the screen was a real pain in the butt and really slowed down trying to set things up. And plus, then if I needed to change something, it was really difficult to go back in and then have to look at the bit pattern again and tweak it and then recompile and test. It just wasn't working out. So what I came up with was this tool that you're seeing now. I call it FontWorx. It was just kind of spur of the moment what came to mind. It was a tool for making fonts called FontWorx. So as you'd expect, the toolbar at the top has your basic options. You can create a new font, you can load an existing one, you can save your current font or save as. The font name here is internal to the font file. It's just a way that you can see in the editor which font you're working on. It's not saved in the file name. You can save the file name to be whatever you want it to be. This just lets you know what you're working on in the editor. The grid here allows you to interactively draw out your font pixel by pixel and to see what it looks like on a larger scale on the fly. So this option set pixel here basically sets the brush to set the bits in the bit pattern. So you can see I can set individual boxes within this grid, and this grid corresponds to the 8 bits of height on the page and then 8 bytes wide. I can also set this clear pixel button, which now basically sets the brush to be like an eraser. And the way this works in the LCD is that a red square equates to a pixel being on in memory, and a white square equates to a pixel being off in memory. I've also got this handy little clear all button right here. This clears just this character, but it clears all the pixels set by this character. And similarly to that, I have an invert button, which inverts the bit pattern for just this character. That didn't really make it clear. So if I draw out like the character A here and I hit invert, you can see that the bits get flipped. I also have an invert all button, which will invert the entire character set, one character at a time. This is really useful if you want to invert the whole font to create maybe an alternate contrast version of the font. Then you could do fun things like if you wanted the font to kind of flash, you could switch between the two fonts or something like that. Go ahead and clear that out. The scroll bar here on the right allows the user to select the active character that they're working on. This box contains all of the visible characters in the ASCII range from 32 to 126 in order. That should be all of your punctuation, characters, upper and lowercase, and numbers. So this allows the user to work through the range of characters one character at a time without having to save individual characters. The work done per character is retained when you select a new character, and this makes the workflow very smooth and simple. You start at the top, you work on the character, and then you work your way down. I've got a font already loaded here so I don't have to make it on the fly, but as you can see, that's what I would do. I'd start at the space, work down, draw this out, draw the next one, and you just work down the list until you get to the last character. Oh, this is missing some characters. Interesting. At the bottom of the window is a text box that displays the current byte set for the font. This isn't strictly necessary for this tool to work, but it gives the user an idea of what the outcome of the character will be in code, and it can kind of help with troubleshooting, especially if things aren't quite looking right. You can see the byte pattern in the editor, and then when you go to look at the code, you might see, oh, maybe something's getting tweaked in the code. So it's just a way to kind of verify what's actually going on. I've got this generate test image button here that allows the user to preview the font in real time. It's in a format similar to what it would look like on an actual LCD display. So this is a great way to actually preview what your font might look like on the target platform. The window also allows you to set the background and the foreground of the font. So if your LCD is colored, for instance, maybe I've seen some that are like orange or something like that. So maybe your background, your backlight is like orange or red, or maybe it's blue or something. You can set the background and the foreground colors to match whatever your LCD might be. It's also got this nice little invert option too, so you can swap the foreground and background colors on the fly if you want to see what it looks like in different contrasts. There's this save button also that allows you to save this preview image as a bitmap image. And this is really great if you want to be able to preview this font outside of the editor. So maybe you want to be able to look at a font and go, oh yeah, I want to look at that font and use that file. Rather than having to fire up the editor, you could just save the preview image and then look at the images to figure out which fonts you want to work with. This generate C code button at the bottom here is the primary method of exporting the fonts to a project. It allows the user to set the name of the variable for C or C++. This will be the name of the array variable that's created. And it allows the user to specify a 1-dimension or a 2-dimension array as the output. A 1-dimension array will be 760 bytes long, where every 8 bytes corresponds to one character. A two-dimensional array will be a 95 by 8 byte array where every entry in the 95 list corresponds to the 8 bytes needed to produce one character. This is the method that I prefer because it maps to ASCII a lot better. All you have to do to map from your ASCII value to the particular font definition is subtract 32 from the ASCII, and that gives you the index into the array. And then all you have to do is pull out the 8 bytes from that particular index in the array and push them straight into the memory of the microcontroller. At the moment, this only copies to clipboard. At the time I was working on this project, that was kind of the way I was doing it. I was working on a single main file, and I didn't want to do includes and stuff like that, and this was just kind of the quick and dirty way to do it. Ideally, I should implement the export to a header file, so then you can just simply include the header file in whatever project you're working on, and then when you export, it'll overwrite the file, and then you don't have to paste it back in. But it was kind of a work in progress, and that's really the only feature that needs to be done to completely finish this project, in my opinion. So I'll go ahead and just kind of look through some of these characters so you can get an idea. I went through one day and tried to do a nice font, and then I used this in several projects with my microcontroller, and I'm really happy with it. The fonts come out nice. It's very easy to set up. This tool is very smooth. It's written in C#, so there's not a whole lot of fuss with it. It was pretty easy to develop because it was C#, and I used Windows Forms. I didn't use WPF, but the Windows Forms worked out pretty nice, and I'm happy with how it came out. So if you're working on any microcontroller projects that happen to have LCDs and you want to be able to write fonts to the screen fairly easily, this might be a tool that you are interested in. It's available on my GitHub page, and I'll post the link in the description. So if you're interested, check it out. Thank you for watching, and I will catch you next time.